I welcome you all to today's lesson, even as we talk about this topic in physics called light. This is a topic that we've started, so I want you to understand it even as I explain it. So, light, what are you supposed to know or understand about light? You discover that light will travel in a straight line. This is the first thing that you need to understand. Light travel in a straight line. So I'm going to make this very simple because these are the major topics that come in your exams. So whenever you are talking about light, is that light travel in a straight line. And this topic is under waves. We know that a wave is a disturbance that occurs on the surface of an object and it is able to transfer energy from one place to the other. And we've got two types of waves. We've got a transverse wave and a longitudinal wave. So light is an example of a transverse wave. We know that a transverse wave is a type of a wave whose particles vibrate perpendicular or at a right angle to the direction of the wave. So this light will travel in a straight line. So light gets to travel in a straight line. And there are only two ways that can change the direction of light. So there are two ways. So we've got two ways to change. So two ways to change. So I wanted to change. So there are two ways to change the direction of light. Two ways to change the direction of light. This is what you need to understand. Two ways in which we can change the direction of light. The first one that you need to understand is called refraction. So refraction can change the direction of light. The second one is called refraction. So refraction can also change the direction of light. So these are the two ways in which the direction of light can be changed. This is what you need to know and understand. So this topic called light, you just need to discuss about these two. You talk about refraction, you talk of refraction. Once you understand these two, then this topic automatically becomes simple, because this is what we are going to major in so much in this topic. So I want you to understand this. I want you to get all the necessary things that you need to know under this, even as I make this topic very simple. So straight away, let us now start looking at the first one, which can change the direction of light, which is refraction. Let us talk about refraction. So this is what we'll start with, called refraction. So we'll start with this one called refraction. So if I ask you a question, what is refraction? Refraction is the bouncing back of light. So this is the bouncing back of light. As simple as this. So refraction is just the bouncing back of light. So when it hits a flat surface, light has to bounce back. So when light bounces back, which means we are talking about refraction. So refraction is just the bouncing back of light. This is what you need to know and understand. This is a bouncing back of light. So this is what gets to happen. So I want you to understand this part. This is what gets to happen. This is a surface. You've got a surface like this. You've got a normal ray. There's this one which we call a normal ray. So we've got a normal ray. This is a normal ray. So we've got a ray that hits the surface. Then we've got a ray that leaves the surface. So what you need to know and understand, this ray that reaches the surface, this surface is called refracting surface. So this surface is called, this is a refracting surface. This is a refracting surface. So I'm going to do this. This is the refracting surface. Call it as the refracting surface. This is the refracting surface. So this ray that reaches the refracting surface, it is called the incident ray. So you get to call this as the incident ray. So an incident ray, this is a ray that reaches the what? The refracting surface. There is a ray here which I've named it the normal ray. So this is the imaginary ray, and it is perpendicular or at a right angle to the refracting surface. And we've got this ray that leaves the refracting surface. So this one that leaves or that bounces back, it is called a refracted ray. This one we call it as a refracted ray. This is what you need to know and understand. We also have an angle that is there. We've got an angle there. We get to denote it by I. So this angle that is here is called the angle of incidence. So the angle that is between the incident ray and the normal ray, it is called the angle of incidence. So I want you people to know this. I want you people to understand this very well. So I want you to get the full information. You understand this properly. So I have said that we've got I there. That one is called angle of what? We get to call it as angle of incidence. So if I tell you that what is an angle of incidence? An angle of incidence, this is the angle that is between the incident ray and the normal ray. That's where we get to find an angle of incidence. So it gets to call it an angle of incidence. We also have an angle which is this other side. That one, say R. So what is the name of that angle? We get to call it, so that one R, we get to call it as angle of refraction. So it is called angle of refraction. Gets to call it as angle of refraction. This is what you need to know and understand. It is called the angle of refraction. So the angle of incidence is between the incident ray and the normal ray. This one is called the incident ray. This one is called the normal ray. Then we've got the angle of refraction. The angle of refraction is between the refracted ray and the normal ray. Make sure you understand these things. If possible, make sure you are writing down some points so that you don't forget this even in an exam. So make sure you understand this. We are going to go deeper in this. So this is just the introduction to this. I want you people to gain some knowledge under this so that even as we get to move forward, you will understand this topic very well and clearly. So I want you people to know this. I want you people to understand this very well. So make sure you get this. Make sure that you understand this. So in an exam, they can give you questions in whatsoever way that they want. So there is an angle there. We know that this angle is between the refracting surface and the refracted ray. This one doesn't have a name. But they will tell you that the angle is between the refracted ray and the refracting surface. Find the angle of refraction. You are able to do that. You know that this part here is making a 90 degrees angle. That is very simple. I believe you are able to do that. You are able to work out that. So now, there is also another part that you need to know and understand. There is another part that you need to know and understand. So there is what we call laws of refraction. There are two laws of refraction that you need to know and understand. There are two laws of refraction. The first one is that the incident ray, this is the first one, incident ray, of course, the incident ray, normal ray, so the incident ray, the normal ray, and so, and let me do this. So due to space, I'm going to do this. And so, and refracted ray, and refracted ray, they all, so they all lie on the same plane. This is the first one that you need to understand. So this is the first law. So the incident ray, I believe this is the incident ray. This is the incident ray. So the incident ray, normal ray, and this one here called the refracted ray, they are all lying on this same plane we are calling a refracting surface. So they all lie on that plane. So this is the first one that you need to know and understand. The second one is that angle of incidence. So angle of incidence, angle of incidence is equal to angle of refraction. So this one is equal to the angle of refraction. This is what you need to understand. Angle of incidence is equal to the angle of refraction. So this is the same as the angle of incidence is equal to the angle of what? Refraction. This is the second one, which I've said the angle of incidence is equal to the angle of refraction. This means that the angle which is here, this angle that is there, is equal to the angle that is there. So if this one is 40 degrees, meaning that one is also 40 degrees. Have you seen? So this is what you need to know. This is what you need to understand. Make sure you understand this part clearly. You understand this very well. So these are simple things. These are simple stuffs that I believe no one can fail. You can't fail this. So I want you people to understand this very well. You get the concept under this. So make sure you know this, you understand this clearly. So make sure you're writing down these points that I'm giving out. So we are going to end here. This is where we are going to end from. This is a simple lecture. This is a simple lesson. This is just the introduction. We are yet to go deeper than this. So what I want you to give you, an exercise that I want you to do, I want you to make some notes. I want you to tell me the incident ray. What is the incident ray? What is the normal ray? What is the refracted ray? And the angle of incidence, where is it located? Angle of refraction, where is it located? So I want you to tell me it is. So you are going to start. This is an exercise that I've given you. I see if you were understanding. So you make some notes. You say you start incidentally. You do this. You tell me incidentally. This is a ray that papa. You do that. Normal ray. So everything normal ray. You also, so you finish everything normal ray. Incident ray, normal ray. reflected ray, angle of incidence, angle of reflection. You tell me everything. So you need to make sure that you tell me everything. So, and I believe there is something that I didn't finish last time. We were talking about sound. I didn't finish this part. So you need to understand this. There's what we call the, so away from reflection, I want us to discuss about this a bit before I conclude. So there's what we call the pitch of sound. The pitch of sound, this one depends on frequency. So the pitch of sound depends on frequency. This one depends on frequency, depends on frequency. So when you see such a question in an exam, just know that this one depends on what? Depends on frequency. And the audible frequency range of a person is from 20 Hz to 20,000 Hz. This is the audible frequency range of every person. You get to hear sound within this range. Anything above this, then it can blow your ears, or less than this range, you can't be able to get any sound. So this is the audible frequency range that you need to know and understand. So the pitch, that's why you discover that the voices of girls are high pitched compared to boys' voice, because they depend on the what? On the frequency. So meaning girls have got a high pitched voice compared to boys. Then there is also what we call loudness of sound. Loudness of sound. For sound to be loud. Loudness of sound. Loudness of sound. So this one depends on, so it depends on amplitude. So it depends on amplitude. The loudness of sound depends on amplitude. This is what you need to know and understand. So the loudness of sound would depend on the amplitude, meaning that the larger the amplitude, it contains the it is going to contain more energy. So the larger the amplitude, more energy it contains, and therefore very loud or louder. This is what you need to know and understand. So this is just a part that I wanted us to revise through. I know from doing sound, so this is the part that I left out. Just wanted you to be updated on this. Don't forget, we are still looking at reflection. So this is where we are going to end from. Hope you've understood something from this. Thank you so much.